Today we're going to look at extrema on an interval. So extrema refers to maximums and minimums. We're going to have two types of maximum and minimums, which you should be familiar with from our conversations last year about characteristics of functions. So we've got quite a few definitions that you just need to record in your notes. The first is that a minimum is a point that's less than or equal to all values of the function on an interval, whereas the maximum is a point that's greater than or equal to all values of the function on the interval. The absolute maximum or minimum is going to be the highest or the lowest overall. An endpoint extrema is going to be when we have an endpoint that is our maximum value or our minimum value. Endpoints can only be absolute or global extrema. Once we get to relative extrema, which is just higher than things in the neighborhood or lower than things in the neighborhood, those are only for points that are inside of our interval. They can't be endpoints. We've got this theorem here, which is quite important as a justification later in free response questions. So this extreme value theorem just says that if we've got a continuous function on a closed interval a to b, there's always going to be a minimum value and a maximum value. Then we've got this idea of relative extrema or local extrema, and that just means that compared to the stuff around it, it's the highest point or it's the lowest point. All right. So that can occur at a corner, a cusp, or just a smooth turn. So a critical number then is going to be anywhere where our derivative equals 0 or if it's not differentiable. So if we're looking at these ones I just drew, the first one has the derivative equal to 0. The second one's a corner, so this is not differentiable. We can't take the derivative at a corner. And we can't take the derivative at a cusp. So similar to a corner, a cusp looks like this. So all of these are critical points, candidates for our relative max or relative min. All right. But specifically, when we're considering these critical points, that's the only location where we can have a relative max or a relative min. Right? So those are our three cases where we have a relative max or relative min. Then we have guidelines for finding extrema on an interval. All right, so this is going to be when we're talking about absolute max and min. We're going to get to how to find a relative max or min in one of the following sections. So this right now is for finding the absolute ones. So our first step is to figure out what our critical numbers are. Our second step is to find the y values at our critical numbers. Our third step is to find the y values at our endpoints. And our last step is to compare those values and determine what our absolute max and absolute min are. So our highest overall point and our lowest overall point. So now let's consider relative extrema. So remember those occur when we have the derivative equal to 0 or we have a non-differentiable point. All right. Here we're going to find the value of the derivative if it exists at each identified extrema, so the points that were given. So since they're relative extrema, we'll expect the derivative to equal 0 at those points. So for our first function, we have x squared over x squared plus 4. We need to find the derivative and set it equal to 0. This guy requires us to use the quotient rule. So our numerator is x squared, our denominator x squared plus 4. Our derivative of each of these functions happens to be the same. All right. So then we substitute into our quotient rule. We're going to simplify the stuff on the numerator. The denominator we're going to leave alone. So to do that, we have to first distribute. All right. So this is our derivative, f prime, for that function. All right. So we're asked to evaluate it at the critical point given. The critical point given is 0, 0. So that means we are going to substitute 0 into this derivative that we've just found. So I've got 8 times 0 over 0 squared plus 4 squared. So 0 divided by 16, or 0. So our derivative comes out to that expected value of 0, and that's what we would expect for a critical point. Moving on, we're going to the next I do problem. So for this one, we have to find our extrema on a closed interval. So first, we're going to start by finding those critical points, which remember is where our derivative equals 0. Then we're going to find the y value at the critical point. Then we're going to find the y value at the endpoints. And using those y values, we're going to identify the absolute max and min. All right, so for the function given, when we're looking for that critical point, we need to do the derivative. The derivative here is -1. -1, we set equal to 0 to find the x value where that occurs. -1 does not have anywhere that it equals 0, right? So this function has no critical point. So since there's no critical point, we skip step 2, and we go straight to step 3, which is to check the y value at those endpoints to figure out what that is. So we've got 4 and we've got 1. So our step 4 says, what's my absolute min? What's my absolute max? Absolute min here is the 0.21. Absolute max is the -1.4. The we do problems are going to get to spots where we actually have critical points. So stay tuned.